everyone. Myself Ullas. Hey, Vastina Madle.
Starter.
Good morning, everyone. Myself Ullas. I am telling about secondary storage. Secondary storage is also called as a non-volatile memory. So data is not lost when a power is off. It is used for a long-term and data storage. It provides a large storage capacity at a low cost, and it is slower than a primary memory RAM, but store more data. Data can be stored for a months or a years. It is mainly used to storing a OS software files, videos, photos, etc. Data is stored in the form of a magnetic disk, optical disk, magnetic taps. For example, in hard disk, SSD, CDVD, it also used to storing a memory and a magnetic disk. Magnetic disk is a type of a secondary storage device. It consists of one or more circular magnetic disk. These disks are mounted on a spindle. Each disk surface is coated with a thin magnetic film. The disk rotate at a uniform speed. A magnetic gate is used for a reading and writing a data. The magnetic gate is magnetizing a coil. During a writing, electrical pulse are applied to a magnetize the disk, and data is stored by catching the polarity of a magnetizing. 0 and 1 bits are storing as a two opposite magnetic states. During a reading, the head detects voltage changes and during this voltage changes occur due to a magnetic field variations. Long sequence of a zeros ones need a synchronized information. Synchronization helps the system read and correctly. Special encoding technique are used. One common method in a pace encoding machines encoding. This encoding combines a clock signal and a data. Magnetic disks are commonly used in a hard disk. They offer a large storage at a low cost, used in a computer servers and data centers. Thank you. Next will be continued by Vikas.
Hello everyone, my name is Vikas. Today I will explain the mechanical structure of magnetic disk and the encoding method used to store and read data. Mechanical structure, the diagram shows the mechanical structure of a magnetic disk. A magnetic disk rotates at a uniform speed on the drive shaft. Over the disk surface, there are multiple read and write heads mounted on axis arms. These yet do not touch the surface of the disk. Instead, they float above it on very thin air gap, which protect the disk from damage. During writing, a current flow through the coil in the head. The current produces a magnetic field, and this magnetic field magnetizes the thin film coated on the disk surface. During reading, when the head moves over a magnetized area, the magnetized field changes. The change induces a voltage in the coil. That induced voltage is detected by the read circuit and interpreted as a bit storing bit zeros and ones. Bits are stored on disk as opposite direction of magnetization. One direction represents zeros and another opposite direction represent as a one. A change in magnetization is called a transition, and the read circuit uses this transitions to detect the stored bit. Manchester encoding. This encoding method ensures that every bit contains a transition in the middle. This middle transition acts as a clock signal. and the direction of transition tells whether the bit is 0 or 1. Next slide is encoding and clocking. During the reading, the disk controller must know the exact boundaries of each bit, but if there are many represented zeros or one, there are many there may be no transitions leading to loss of synchronization. To avoid this issue, this uses Manchester encoding, which generates at least one transition in every bit period. Each bit interval is divided into two halves, and the mandatory mid-bit transition is used to clocking the direction of transition represents the data value. Thank you.
So, good evening, everyone. Today I'm going to explain the topic of organization of data on a disk. The disk has many circular rings called tracks. Every track is cut into small slices called sectors. Outer tracks are bigger so they can store more data because of their circumference. An index mark shows where each track starts, means every circle has a initial mark. This tells the header to read the data from there. Each sector has a header that tells its track number and sector number, as you can see in this diagram. The read write head moves in and out radially to reach different tracks, means head moves left or right to reach the correct track where the data is present. So when the disk spins, a sector pass under the head in the same order every time, means the sectors move in the sequence under the head. So tracks at the same position on different disk surface form a cylinders. So accessing data on a disk. Data inside a sector is kept in a straight ordered way. Every sector starts with a small header that tells the disk which sector it is. There are also ECC bits that help fix small errors. ECC means error correcting codes. The disk controller reads the header to quickly find the right sector. The head can read or write only from the beginning of the sector. Access time has two parts, that is seek time and rotational latency. Moving the header to the right track is known as a seek time. So waiting for the sector to rotate under the head is known as a rotational latency. A cylinder allows faster reading because the head can switch between the surfaces without moving.
Hello everyone, I am Shreyas. Today my subtopic is access time. Here, access time means the amount of time for the actual data transfer. It has two types. One is seek time and another is rotational delay. What is seek time? Like seek time, it is the time needed to move for a read or write to, from head to the correct track. Like it depends on the initial position, and its typical values are from 5 to 8 milliseconds. Rotational delay means it is the latency or delay. It is the amount of time waited for the data to rotate under head. Like its average rotational delay is about half of a rotation of a disk, and its formula is like total access time is equals to seek time plus rotational delay, and also it is larger than the actual data transfer time. And second is data buffer. Data buffer or H memory. This means like a disk drive connects a computer using the like bus. that can transfer data from one disk to another disk. It handles speed difference. Disk includes like a buffer made of semiconductor memory, like it uses a few megabytes in this side, and data is moved to disk surface into the buffer, depending on disk rotate. It also depends on rotation speed. Um, and the buffer also works on an edge, like it stores recently data. It can be sent again quickly if any user or requested. The buffer also works as an temporary memory, like storing recently data. If the requested data is already in the temporary memory or edge, the disk can supply it in a microsecond. It's much faster than the reading from the platter. And the disk controller may load extra sectors into like read or write, because future requests are likely to be neighboring data. Okay, thank you.